Bismillah ar-Rahman ar-Rahim. Ladies and gentlemen, welcome to the first seminar of Arab Basalt Fiber Company. We're happy to have you on our first of its kind seminar that you will soon see more of it, inshallah, in the coming few quarters. Our objective in this seminar first, as announced in the publication, is that to meet you in person and connect with you on a more deeper level to understand your needs and to also convey a clear picture about the product. We are joined here with our colleagues, Mr. Taha Khawaldi. He is the General Manager of Arab Basalt Fiber Company and Arab Basalt and Arab Mining Fujairah, and also with Engineer Basil Rawas as well, who is heading the project of the production, of the building of the facility, and also with Engineer Muhammad Zumeli, and our colleagues as well, Mr. Malcolm Newton and Mr. Yuri Granfield, and myself, Hudayfa Nawafle. So our presentation today is divided into three parts. The first part, we will go through a general introduction about the product, the characteristics and the composite details of the product. Then we will take your questions and address them by our team joined here today. And afterward, we have a keynote from the Fujairah Natural Resources Corporation, which I believe they have something valuable to share with you. So without further ado, I will give the mic to Mr. Taha Khawaldi to give the general introduction. And after that, we start with Engineer Basil. Thank you.
بسم الله الرحمن الرحيم. السيدات والسادة السلام عليكم ورحمة الله وبركاته. بداية اسمحوا لي وبالأصالة عن نفسي ونيابة عن الرئيس وأعضاء مجلس إدارة الشركة العربية لتأديب الفجيرة والشركة العربية لألياف البازلت بأن نتقدم لكم بخالص الشكر والتقدير على تلبيتكم دعوتنا واهتمامكم بمشروع إنتاج وألياف قضبان البازلت. كما ولا يسعني في هذه المناسبة إلا أن أتقدم إلى الجهات الحكومية في إمارة الفجيرة والتي لعبت دورا كبيرا في دعم هذا المشروع وساهمت في إنجاحه، وعلى رأسها بلدية الفجيرة ومؤسسة الفجيرة للموارد الطبيعية، بالإضافة إلى الأخوة المعنيين في دائرة الجيولوجيا والثروة المعدنية في وزارة الطاقة والبنى التحتية. وكما ذكر الأخ حذيفة بأن لقاءنا هذا اليوم هو بهدف التعريف بأهمية ألياف قضبان البازلت وميزاتها واستخداماتها في العديد من التطبيقات الإنشائية والصناعية المتقدمة. فنفتح المجال الآن للمهندس باسل الرواس لتقديم عرضه على حضراتكم، وأهلا وسهلا فيكم جميعا. شكرا لكم.
Welcome everybody. First, we will start in explaining what is actually the basalt fiber and what is the products come out of this fiber. Basically, the basalt fiber come from starting from the basalt rock, which this rock is available in several parts of the world, Fujairah Emirat and United Arab Emirates. These rocks goes through several processes until it reach to the basalt products, which is firstly it gets melted into certain furnaces, and it end up as a first product these fibers. As we can see here, these the first fibers come out of the furnaces after melting these rocks into a high degree, 1400 degree. After generating and reaching these fibers goes into further process to generate several products, in which among the main one is the bars. The bars that we are now introducing to your guys, gentlemen, and compare it with the traditional reinforcement, steel reinforcement bars. So we'll talk about the characteristics and properties of these rebars and how these are benefiting and has further advantage comparing with the traditional reinforcement which we are using currently in the construction. As a simple comparison, why we are using these and what is, before we go to exactly the technical comparison and the numbers. Firstly, these have rust resistance. It has more environmental carbon footprint, for 74% less than the iron. The sustainability, the total overall cost, safety and security as a weight. The weight of those is much less than the steel, is 4.5 times less than the steel weight. So all this is reflect on the application, on the logistic, on the the logistic where we transport the steel to the construction areas and site, to the overall weight and application of the reinforcement in the building, and so the age of those, the corrosion of those, all the other expansion coefficients, the coverage, concrete coverage, the electromagnetic field, how would make that advantage in some application, like in the hospitals, MRI places. Thermally and acoustics insulation, total cost, as we said, for the long term, and other characteristics like the tensile. The main properties of this, comparing with the steel, is the tensile. These bars has like 2.5 times more tensile strength comparing with the traditional reinforcement, the steel reinforcement. So that gives this advantage in terms of weight plus the tensile characteristic. That is in general for the reason, for the properties, for the lifespan, corrosion, and other application which we can brief also where we can use those for those and which application and where has been used already. Mainly those widely or worldwide has been used in roads with asphalt, in protection works of roads, channels, reinforcement of road slopes, construction of concrete playgrounds and floors, hydraulic structure, bridges, water treatment facilities, civil and industrial construction. It has been used widely now in the military also, manufacturing, and the space, structure of cars, ships, not just the bars. The fiber itself goes into different product, like even internally cladding, internal cladding, external cladding. It has been used in UAE in Burj Khalifa and Khalifa Tower, and also in the Louvre Museum. So that's the first application of this product in UAE. Also, it has been used in several examples of projects worldwide in Ukraine, in Russia, and Kazakhstan, in UK. We can name some projects which has been used worldwide. Firstly, this product has been invented firstly by a French guy called Paul Ducan in 1923, who has introduced the idea of producing these basalt fiber. And in 1960, the United of America and Russia has started the research in the application of those in military and secretive industry. Then, for the first time, this has been produced in industrial level in Ukraine in 1985. And then it started wider researches on it, until the 90s, the early 90s, 1991. China started to develop those basalt from the beginning of 2002. And here we are in UAE and in Fujairah. We launched our project in 2020 as a first institute, first factory to produce those fibers and the bars as the main product for these fibers. Other applications, there is wide application worldwide, like in the gas pipe, in the insulation, the protection from fire, and as I said, in the vehicles and cars and ships industry. There is wide because these used to reinforce the materials similar to the glass fiber. And start now replacing the glass fiber worldwide. We can mention some other example of projects which these has been used worldwide in the wind in the energy project in Galloway in Ireland. This one has been used. It's been used in Russia in the airport of Ulan-Ude. To support and consolidate the road, internal road in the airport. Also, there is a factory of ship factory in Germany has been used. There is some in Sweden. There is some a bridge called the Hjulsta Bridge has been those bars has been used in this bridge, and there's many other several examples. Maybe we can. Show you, like in Kazakhstan, there's some residential complex has been used also in Ukraine in one of the airports called Borisov. And other one there are several also in Ukraine. In UAE, as I said, the Khalifa Tower and in Louvre Museum, these were used as supporting some cladding, internal cladding, which has given the acoustical and the thermal insulation in where has been used.
All right. Thank you very much, Engineer Basil, for the introduction. Again, everyone, the purpose of this orientation is, to open the dialogue. I believe much of this information you've been seeing for a while online on our YouTube channels and social media channels everywhere, right? So. Today we want to have your questions since we have the experts today. I believe you have a lot of questions which we can get some of them, like for example price and how we can compare that to the steel and which is cost efficient and how. Also some maybe technical questions. That's why we have everyone here to answer your questions. And of course also you will have a chance to see the product or touch the product yourself. As you can see in the back table we have some samples. And here we have some fiber samples and some rebar itself. So without further ado, if you have any questions, let's start orienting the questions. Can you help me please with the microphone? Thank you. So this gentleman here, we'll start with you.
Engineer Muhammad Zakaria. Maybe I want to ask about compression stress for the basalt. Compared with the steel.
The tensile, it had currently there is a comparison, scientific comparison has been it's coming through between exactly the characteristic of the steel and the properties of this basalt, which will show you all the aspect of the two in a PhD study and master degree. They're both undertaking the comparison study for all characteristics and properties of the product, including compression, tensile, and all other things, and also yielding and things. Currently, these cannot be bent site-wise. It can be bent factory-wise. There is certain machinery which can bend this, and there is an example there. You can see how those has been bended factory-wise. This study and this exactly scientific comparison, we can share it later on, when we have it in further opportunity.
Sure. Any other questions, guys? The gentleman there. Maybe we give this to Mr. Yuri or Malcolm, the microphone. So again, this is just to show you how it's bent and the factory-wise, so production-wise. Walaikum salam.
Okay.
Fujairah Natural Resources Corporation. Just I want to ask about applying of this product. Any approval from municipality? We need to approve from any municipality here in United Arab Emirates, same like Dubai municipality or Fujairah municipality, to say this is a good product.
Thank you very much. My name is Yuri Ganfeld and I'm technology provider to our mining company. We have been producing and installing BFRP rebars in UK and US for a while, for a number of years. Now, regarding, we have a EPC contracting company here, and we have also EPC contracted to our mining company. We have received the approval from Fujairah and Dubai municipality if we use BFRP rebars in construction. We actually, in the factory of our mining, for all the foundation and slabs on grade, we used BFRP rebars which were approved by Fujairah municipality.
What about codes?
There are ACI codes available, which includes BFRP rebar CSI. It's a Canadian code, includes BFRP rebars. Euro codes in 2024 will include FRP rebars. In the UK, we have our rebars are certified by BBAs, the British Board of Agreement, and the rebars here will be certified to ACI and to Euro codes. Maybe Malcolm.
Important, this is very important, codes, because the first thing that any construction company is going to do is going to get the building designed, and the designers, the Atkins and the Jacobs of this world, will want to have codes to work with. So we're conscious of the fact that we have to introduce codes to our basalt bar here. And just to go, what Yuri has just said is absolutely correct. Euro codes are very important. Euro codes don't actually include FRP bar of any kind at the moment, but in our structural engineers, we have structural engineers working for us in our factory in the UK, and our structural lead has designed a way of designing, converting steel structures to basalt structures within the Euro code. So we can actually apply that and then provide a PI, professional indemnity, for the basalt bar. And we intend to do the same here. Thank you.
Other questions? Yeah, sir. Okay.
ACI code which number?
Let's take the microphone so we can just get your voice. Yeah.
Hello. Yeah. ACI code which clause, which number? ACI code?
Yeah, 490 ASTM D7957. Yeah, 490. Yeah.
I think I had a look at this code. It's not a design code that specifies the criteria for design, but it just gives you as a go-ahead with Basalt to use it in construction, but I never find any criteria. So what you are saying, sir, basically that we cannot adopt that in our designs until you come up with a global or worldwide recognized code, because you mentioned the ACI, the CSI, the Eurocode, but I didn't find any criteria for that. So we cannot come and replace the tensile strength with 2.5 multiplied with 500 steel, because we have other things like elasticity. Do you have tensile? Do you have uniaxial tensile test that show the elasticity? And also, what about the ductility compared to steel? Because steel is very safe material in ductility. It gives us a lot of warning before doing failure. Yeah. So all these questions, are they answered yet, or we still have to wait until we can use it in proper structured design with approved criteria?
All these questions actually are answered in ACI codes. There is actually codes how you build using BFRP rebars. There are safety factors. There is no yield with yield strength with basalt rebars. So, but they have a high tensile strength. So you don't design until the fracture. There is a safety factors, and they're very conservative in the ACI codes. Now we can design under Euro codes based on material properties. So we do the tests, and we use these material properties and some ACI guidance. We can design and sign off the design using these material properties under Eurocodes. It's also possible. I mean, exactly the codes number and everything, we can share it with you, but it's widely available. It's ACI codes. There is international building codes, which are also certified to, which includes Basalt FRP Rebars. We've got certification for this from it's International Code Council, ICC.
National code.
International Building Codes. ICC. ICC in ACI. ICC using their codes and also ACI codes for the design.
Yeah, but when we come to something like the minimum reinforcement for the shrinkage and other things in
they all provide this. There is a factors.
Yes, the factors. I mean, are we going to use the effective 2.5 multiplied it in?
No, it's not like
so. Or we have to sacrifice some of these strengths on the expense of providing proper reinforcement for the concrete, because concrete is very brittle material. It shrinks, it cracks. So what about the minimum reinforcement for that? If we are going to use the minimum reinforcement as the criteria, then we are not using the full effectiveness of this tensile strength, I believe so.
Sure,
initial ideas comes to my mind.
Even after the reduction in safety factors, the tensile strength is higher than steel rebars. We used it very a lot in UK, apart from, so for example, at the moment, we're using it for the large project, it's Canvey Islands, and there are structural, quite, we got this contract about 3-4 months ago, and we're supplying it, quite a big project. If it's signed off by environment agency, it's a government in Jacobs. Jacobs designers signed it off. And they've seeing benefit of using basalt rebars against steels.
Yeah, when you say island, of course I understand there's some marine structures.
Yeah, I think that the important thing is, as I think I said earlier, is that, it's signing off with designers. So what we do and you didn't find in the Eurocodes any mention of FRP bar, because it's not going to be in the Eurocodes until 24. However, you will find the annex, arranged the annex allowance, which I'll give you actually separate to this seminar, and explaining how we can use Eurocodes to design within the framework of the rest. So as a designer, which I guess you probably are, and I expect you these sort of questions. As a designer, what we would do is we would have to educate you. I'm not trying to tell you that we've got to educate you on structural engineering, but how to use basalt values with steel designs. So what our structural engineer does, and this is very simple, we're doing 3 projects at the moment which are quite considerable. One is for a company called Mace, who are an international tier 1, and they have their own design team, and what they're doing some suspended slabs on some new building in London. It's called Edge. Now, what we've done with them, they've given a steel design to our structural lead, and then he redesigned it with basalt, gave them back the values and the full description of how you achieve those designs, and they've accepted it and written it off. And that's what we would do with you guys. And the same goes for a company called Skanska, who are also a big company, and they're working on HS2, which is a big rail. I don't know how much you know about the UK, maybe a lot, maybe not so much. There's a big rail project called HS2, and Skanska are one of the consortium, and we're doing 2 construction detailed slabs and work for them, and some structural work where we've redesigned the steel work, and it's been signed off by their designers, who are, I think, Arab. So what we're saying with this is that, number one, we have the codes, and all the testing, for creep test, elasticity, modulus of elasticity is lower, much lower than the steel, and we know that, we accept that, and we deal with that. But when it comes to flexural stress, all those things, all those tests have been done within our BBA, our British Board of Agrimont test. And we have all the data for that. That's all done by UCAS laboratories. And we also test ourselves in our own laboratories in London for the tensile strengths and the flexural strengths. And we're doing that week by week, because as we do new designs, we test under the Eurocodes, we can do our own testing, and we're doing some Dow testing at the moment because we're quoting for a job at Dover ports. You know, so what these are slabs that run into the sea. Now, not generally slabs, not a problem, but these are 25-year life. So it gives a big problem in terms of flexural strengths and timing. So what I think is you have to understand is it's not the same as steel in any way, shape or form. Therefore, your design codes have to be different and the design strategy has to be different. So to sit here and say, it's great stuff, it's marvelous, it's, you pick it up, it's like everyone says, oh, this is fantastic. But, a structural engineer like yourselves, a structural designer say, oh, it's great, but I've got to have a professional indemnity sign-off. And we know that, we understand that fully. So what we work towards here in the UAE is a professional indemnity sign-off via our structural engineers educating engineers like yourselves. And we're already dealing with Jacobs, and Jacobs I think are quite prominent here. We're dealing with, working with Atkins, and we're working with Arup, and we're working with Haskinen. So all these companies we're actually working with, and they know us quite well in the UK. So I don't think it's going to be a hard ride to persuade the engineers here. But it's going to be a hard ride for us to persuade you away from steel, because you grew up with steel. We've all grown up with steel. It's been around for hundreds of years. So coming along with a new product. But all I'd say is that amazingly, it's been adopted in the United States in a big way, especially in Florida. And the main reason for that, I think, is number one, it's of course it's completely resistant to alkali and salt. So in terms of a very marine area, it's perfect for that product. But number two, it's an environmentally friendly product. It's 60% less carbon footprint than steel. It's a no-brainer really. You're going to use it. But the Americans have done a whole lot. So our company in the United States, which is based in Winchester, have they've just signed on or been certified by the Florida Department of Transportation to provide basalt bar for the construction industry there. Now they're already using basalt bar, but before, even though you have the ACI codes, which they have, and ASTM codes, they've got those. They paid $150,000 or something I pay for it. We had to. Florida Department of Transport had their own codes. They had their own. They said, well, that's fine, but we don't really accept that. So you've got to do, and we do all the same tests more or less for them. They've done that, and now they're certified for contracting to them. And they've embraced basalt fiber reinforced polymer bar over glass fiber reinforced polymer bar, and I'll tell you why that is in a minute. But because it's a better solution for them, and it's proving to be a long-term solution. So I think what we need to look at, and I think for what we need to supply you guys with some case studies. It's not a sale. It sells itself on its look and everything else, but it's a technical sale. And at the end of the day, what's driving it forward in the UK is the fact that if you go to a finance house, go to an insurance company or bank to borrow $200 million or $300 million or pounds to build a complex or a factory or a highway, the first thing they say to you is, one of the things you have to tick is the green box. What's your green credential? And up until we came along, and you remember everybody that in construction, you'll know this, the three culprits for high carbon are asphalt, concrete, and steel. Yeah. And we just reduced steel by 60%. So they can say that. You can't say biofuel anymore because that doesn't work.
Maybe we'll open more room for more questions. So for the time, no problem. Yeah. Okay. So
I'll come back to you anytime on that.
Yeah. Okay. Can we get your question on the mic for the camera? Yeah.
I think everybody here is not come as a defender for the normal or enforcement bar. You come here to support.
Yeah. But you have doubts, but we need to clarify that.
Also, as a engineering consultancy office, we think for free requirement, I think we should think to support. First of all, the consultant, I think now, which software we can use.
Yeah.
That's very important.
Yeah.
And supported code, as we say, and also authority approvals. The third important thing, we should think about the clients. What we submit to the client. Client, okay, he can. Because as we say in Arabic, كل شيء جديد بتكره الغلط. Everything new, everybody needs. That's because difficult to ask a client change your mind for your villa or for your building from normal reinforcement bar to the Basalt. It's very difficult. Okay, somebody think about the bricks, number one, but no, we should
Safety, reliability.
safety and the quality.
Yeah.
And sure, sustainability. The client will not think about environmental sustainability. Back of them they will think, but no. This is also responsibility of the ministries. I don't know. I think some of the ministries here.
Yeah.
They should push.
As a
the client.
policymaker.
When the client he see this is it will come in the government project, easily they will accept. You should think about some government project. And to make a GV with a consultant to support them with the software program for the design, also with the authority approval, and some more seminar and also marketing with the client.
Yeah.
And consultant as an engineer, we agree. We know some challenges that will come, but we need to pass. I know some consultants worldwide they are using, but here still.
Maybe I can add some point here to the when it comes to educating the end users. Let's say we're talking about the clients, the one who's using the. It is surprising even to us that there is that much of interest from the end users onto the product, and they really want it. Their only concern, maybe when from a customer point of view, is that is the consultants aware of this? Can they process this? Are they capable of working with the Basalt? How do they do the quantity calculations?
Software design, that's
Yeah,
all.
yeah.
And how we can deal with the municipality for procedure and approval.
Maybe Mr.
Now for any project,
Muhandis,
municipality
Ismaili,
ask for the
maybe-
design for the calculation.
Can I just make on in terms of costing, price, and is a big thing. I mean, we get it all the time in the UK. I mean, what's the cost of it? Is it cost viable? Can we? And one important point, and this is very important in concrete structures, and you'll know this, that you tend to, because on we do in the UK, and I'm sure you do here, allow 20% extra cover to protect the steel from ingress. Well, guess what? When you haven't got steel, you don't have 20% extra cover. So on a project we just recently did at Lydd in Kent for the Environment Agency, it was a roadway, a permanent road, and it was a 5 metre by 4 metre slab road, 2 kilometres long, and we saved 20% of the concrete cover on that road, and by in overall saving on the project against using steel and concrete, we saved about 160,000, 120,000 pounds, which is quite a substantial saving. So that's against using steel. It's just an example of how you can, work out, and I think as Basil said earlier, it's not question. There's lots of areas that you have to work in, logistics and concrete cover, when you talk about saving money.
Sorry.
Just regarding the software, there is no software available we use for Basalt Rebar. So we design our own kind of system approach using the codes. So we can. That's why Malcolm mentioned that we run workshops and we educate the specialist engineers how to approach, how to convert the steel. We can either convert the steel rebar structure, or we can design using the Basalt rebars, using ACI, CSA, or Eurocodes, based on our mechanical properties data.
Yeah. Maybe there is a question here. I see, right?
Also here
Yeah. Okay. Okay. Sorry. You're into this. Okay.
Assalamu alaikum.
Alaikum salam wa rahmatullah.
Engineer Ahmed Abdel Hamid from Sharjah Municipality. Al-Mudan area, it's a branch from Sharjah.
Yeah, welcome.
Actually, I was planning to make this seminar or repeat this seminar in my area as my annual goal.
Would be glad to work with you. No problem.
Thanks a lot. This area is very important because it's located on the boundaries between Abu Dhabi and Sharjah, and it is a developing area. If I want to tell the owners, consultants, contractors about this product, they will ask 2 questions about the cost and availability in the markets. If we make competition or comparison between the more by steel and this.
Yeah, good question.
Thanks.
Thank you very much. I think maybe
Yeah.
you, yeah.
Right.
Yeah, I think that the client's going to be, of course, interested in costing and go to market. So as cost concerned, if you present him with a meter for meter price, and you can't compare, you don't do costing on tonnage, you know, that's something that, because of the 4.5 times lighter, it doesn't work. But what we have a formula to quote per meter at the price inclusive of all the logistical saving and concrete saving. So what we would do, we would quote a per meter price, but a per meter price of the actual product, but a per meter price inclusive of the saving. So, you know, it will be closer to, you know, very close to the steel prices. And then it could, because it's the logistics saving, cover saving, handling, just moving it around. So those will go in.
Maybe we can demonstrate the light of this.
Yeah.
So see, this is just the regular steel, and this is the basalt fiber. So see, this is really light. You will have a sense of testing this yourself now and just during the break. So that's why we can't go for weight when it comes to pricing. It's yeah.
Oh, per meter.
Per meter, yeah, per meter. Yeah, per meter. That's correct. Okay.
For one building.
That's for the quantities, because it's 4.5 times lighter. The steel is lighter than the the basalt is lighter than the steel. I think we have a question there, right? Yeah. Okay.
I also wanted to add a couple of points on environmental advantages of BFRP rebars, because we've got a lot of, all the countries sign up for the reduction in carbon, and it's in UK and Europe is a big thing. UAE also in Saudi.
Yes.
So Saudi building a number of cities where they want to be carbon neutral, so be negative in carbon. And our rebars, this is a solution. It's better than glass, it's better than carbon, it's better than steel. It has less imported carbon, between 74 to 60% to steel, depending which kind of steel you use. So this is one of the main factors we sell in Europe, in the US, reduction in carbon. And sometimes company doesn't really, the owners of the project, they have actually pressure from the government to reduce carbon in new structures. Regarding the competition, there is no any competition here. Arab Mining will be the only producer of BFRP rebars in the Gulf region.
In the MENA region entirely, yeah. In the Middle East and North Africa.
I did say earlier about glass fiber, because you will hear about glass fiber bar, especially in Saudi, because there is a production facility there. And frankly, it got that we weren't around, so obviously they couldn't find Basalt. And Aramco are one of the companies that use it and are using it. We will make inroads into that market, because the problem with glass is not a product that you can put into landfill. Finally, it has its LCA is not practical. The difference between glass and basalt is this: is when glass is made, it's a process of course, silicate, but lots of chemicals go into that, one of which is boron. And these are nasty chemicals that if you were to, at the end of life, and break up, which you do, structures come to the end of life, there's nothing you can do with that fiber other than burn it. You cannot put it back for landfill, you can't reuse it because the chemicals won't, and so therefore and that's why there's so many boat hulls. You get boats and the boats that, old boats around the world, they can't do anything with. Whereas basalt is purely rock, it's purely basalt rock melted. It's simple and as easy as that. There's no additives. And if you have to, at the end of life, you put it back to landfill, which is a major thing. So going back to Saudi, where we'll make our inroads there, we haven't yet because we haven't got a product to sell. But we have actually. Our UK company has been dealing with some companies there, very interested in using basalt bar because of as Yuri said, the 2020 vision that they have, and they're promoting all these environmental low. And of course, here's the same. There's an environmental. Of course, I think one of the gentlemen said the government push. You said earlier, which is right. But we will jump on the back of that, but you will see in Saudi they already have FRP,
So it's going to be easier for us to replace that FRP without FRP. Price for price will be about the same. So it's, just to give you a background on it. Sorry.
Right, I think we have one more question here, right? Please. Fiber? Stone? Ah, stirrups, okay. So, here we go. And then the high relax one. Just pass it to one of the movers. And fiber, what is that?
هذا يتبهدل
Okay, we have a question here about the strength of when you do the stirrup like that. So, is this vulnerable? This area?
Okay, that's a stirrup, which I think everyone recognizes.
Any potential of cracks or external edge cracks? External edge.
Yeah.
On the external edge.
When you are building.
How it's done, or the strength.
Both.
Okay.
Is there a potential risk on that?
Okay. There's a strength reduction on the bends of about 40%. But bearing in mind that it's 1.6 MPa against steel, which is 400, so it's always going to be stronger in tensile strength, even on the bends. How we produce it is we produce it in the same way as we do our lineal bar. So when it comes, it goes through the resin baths and it's impregnated with the resin. It's overwound with the ribs, and then it also goes through into, once it goes, normally in the lineal bar, it goes into curing tunnels. I won't go into a lot of detail of it because it's, we have a lot of time, but it goes into its cure. What we do here, we put it onto a mandrel, and these mandrels are set at different sizes, and we can set any shape. So we can do any forward shape, and so we can do probably 70, I think 80%, isn't it, Yuri? 80% of the standard shape codes that you have in the construction industry. So stirrups, left-hand bends, right-hand bends. Where we have a problem is, these, if you're making a chair, I don't know if you know what I mean by a chair, a chair for concrete, and it has a U-bend with two-way outside, goes one with the legs going either way, but that's not, you can't do that. But generally, most like U-bends, stirrups, right-angle bends, circular shape codes we can do, and it's all done. And we will have in our factory here down in our hill, we'll have a shape bend line that will be shape bends as well, so we'll be able to do shapes. But it cannot be bent, and this is and I just reiterate what was said earlier. It can't be bent retrospectively. So going on site and getting the old blowtorch out and bending, that's not going to happen. But the whole thing, if you look at a lot of steel shape codes, and I've seen steel shape codes that have been produced here on our site, and they're not terribly accurate. Ours are very accurate because they're made on a jig in the factory, so they're more accurate in terms of size. And they are, you can move them. You can't bend them, you can't heat them, but you can move them. There's a lot of spring there, so you can move them around. Okay.
So how about mix it with the steel and having this steel for conventional connection?
Mix and match.
Yes.
Yeah.
And then we need this one.
Okay.
In the high stress area.
Yeah.
Mid of the
You're correct.
Yeah, absolutely. Yeah, you can mix
It
them.
will be more practical for contractors because they cannot
Absolutely. And the lapping sizes are slightly different values from basalt and steel. I mean, when you're lapping. What's great about this, we made the mesh up on site here, 9 meter by 9 meter. What's great is that you can make mesh in the factory, and you can make it up to 4 meters wide. So whereas with steel, if you buy mesh, steel mesh, 2.4, 4.8 is biggest in 10 millimeter bar because it's so heavy, you can't move it. But with this, that bar, if you had that in 2.4 by 4.8, you'd lift it.
Yeah.
One person would lift it.
Yeah, one person literally, and maybe like in terms of also transporting this, what you need, like six lorries or 6 trucks of steel can be fit in terms of the quantity in one truck of basalt fiber. So imagine how that is,
So what it does, it means that if you're doing a roadway, and we did this roadway in the UK, it's 4 meters wide and 5 meter slabs. You actually deliver to site 4 meter mesh, so you don't have lapping. You cut down fixing. Now, fixing costs on the building side are quite high. I don't know what they are in the UAE actually, but in the UK, it's about £700 a tonne. So it's something you have to save on. And that's the other thing.
There's a question about the thermal extension.
I'm asking about, I'm Mahmoud Ghaboni from Cable Consultant. I'm asking about thermal extension compared to the traditional steel.
It's very similar to concrete. Very similar to concrete. So thermal extension, the same as concrete.
So assuring
because it's a stone. You see, we are, as Malcolm mentioned, we are natural fiber. So it's just it's a 80% stone and 20% resin. So there is no other chemicals added. So it's the same thermal expansion as a concrete in comparison to steel, which helps.
Yeah. It's just to, maybe to give you again a sense of touching that. See, this is literally like a fire. Just a fiber.
It takes a similar properties of basalt rock.
This is 100% raw. There is nothing else there, just 100% raw.
No resin.
Yeah.
Some of the applications of the fiber is also fire-resistant clothes or materials.
Textile industry, yes.
And this is the rock which is around you. So this is exactly the same rock.
Yeah, right behind you, look out the window, that's where it is. There's, you know, 1 million tons of it there.
Basalt, gabbro, diorite, yeah.
Yeah, I mean, gabbro is very similar, it's the same basalt, it's just older.
Factor that has very strong relation with optical scope.
Yeah, sure.
Same efficiency with
صح ما يحتاج اي طلاء او اي بروتكشن يعني مثل بعض الاستخدامات مثل الستيل يعني وكان سؤالك على الكراكس هو هذا انت الحديد تعرف فاينل برودكت كنا عم نحنيه هذا
I just wanted also to add a couple of words of uniqueness of this factory that is built in Fujairah, because they're going to use local basalt which is next to the factory. It's quite a unique situation. Because of this, the embodied carbon is going to be much less than any other BFRP rebars produced in the world, because everything is in one place.
Yeah, and I think there's also a state-of-the-art factory which will be, and it's going to be the biggest factory, I think I'm safe to say this, outside China. And the Chinese factories that are bigger than this don't produce rebar, they produce textile for the pre-preg industry. So, yeah, it's going to be quite unique for some time to come. So I expect it to be successful in that respect.
About the fire resistance of the product?
The fire resistance of the fiber is about up to 750 degrees. You are limited in the rebar by the resin. So resin is fire resistant, but it's a melt if it goes over 300 degrees. However, you can use this, you use additional cover to protect it, but it's certified to use normal structures as steel. However, the fiber itself is fire resistance material. It's used for the fire installation.
I think we have another question there.
Yes, Dr. Haytham from Fujairah Natural Resources Corporation. Just please regarding fire protection again, because I didn't hear.
Okay.
And comply with which international code regarding fire protection?
Yeah, the fiber itself is a fire resistant to 750 degrees. Its melting temperature 1300 degrees. So it's used for a thermal insulation.
Comply with which standard? Comply with which international standard? Which international code?
Yeah, it's
UK, US.
Yeah, we've got it's comply with ACI codes.
ISO 1040 1 to 2008 as well.
Yeah, I mean this is for the production, but it complies with ACI codes for the construction.
Good morning. Khalid from Environmental.
Okay, we have one. Please go ahead.
Yes, my question is the binder. You mentioned 80% rock and 20% is the resin. Are you talking about epoxy resins or are you talking about binders?
We can use any resin. We can use epoxy, polyester, vinyl ester. We can use fire resistance resin. I mean, for our production, we use epoxy resin, but we can use any type of resin.
All right, I think that sums up the questions. Again, I just want to reinforce the idea that we are reachable, we are within your reach through email, through telephone, through social media. As I mean, most of you, if you are here, then that means you have our email, and we'll be more than happy to answer any of your questions now or then. And also, this is just the beginning of a series of seminars that will be carried out over the coming few months, inshallah, all around the UAE. And we'll be more than happy to meet you again with more technical details and specs about the product. For now, we'll, if there are no other questions, we'll move to...
Excuse me, can I just before we finish?
Yeah, please.
Yuri and I are here, but it really came clear to me this morning talking to you guys that there's a lot more questions to be answered. So we're happy to set up individual
seminars, yeah, presentations.
We call them CPDs in LOI.
Yeah.
It's continued progressive development, some fancy name, but it's a presentation, do an hour presentation or an hour and a half with our designers to explain in detail, you know, and if it's more individualized and more, you know, more localized, we're happy to do that. And what we'll do within ourselves, that's what we do. That's how we start. So we're happy to do that, set that up with any of you guys if you want some more information.
Thank you very much, Yuri, for bringing this.
By the way, how much per ton? How much it cost?
Yeah, that's a good question.
We don't sell it by ton. We sell it by meter in diameter. So it's a different prices depending on the diameter. So the price structure is not sold by ton.
It's 4.5.
How we can compare?
Yeah, and you compare on the. Yeah, you compare on the, once you've got the design in steel, you can compare. But it's not sold by tons.
So can we say just generally that rebar 10 mm is equivalent to 60 mm of steel?
Yeah, it depends. It
so
depends.
If you can give us the price of 10 mm, we can...
no, we can give you that, but you cannot compare it like for like. In some instances, you substitute larger diameters with smaller diameters. Yeah. In some instances, you put more BFRP rebars than steel. It depends.
Way, how much the saving?
Saving 30% at least, maybe more on the structure.
Yeah, that's in general. And we're working on a more comprehensive calculator, like digital calculator, to help you come up with that soon. And thank you very much. Looking forward to see you again soon in the next seminar. And we will produce a video based on what we have covered today. We'll share it with you through the emails. We will send you more details, technical information this time by email, a PDF with the specifications, and also we will have an open connection between you and the gentleman here, Mr. Yuri and Mr. Malcolm as well, for the fancy workshop that they have referred to, which I forgot the name of it. So whatever that name is, we'll connect you with that. Thank you very much again, and good luck. Thank you.